All right, today we're going to talk about the circumcenter and incenter of a triangle.
This is for Mr. Van.
Oh, nice. Thank you. Okay, circumcenter first. Circumcenter of a triangle is where the perpendicular bisectors meet. And is equidistant from the vertices. So it's where the perpendicular bisectors of each side meet, and that point is the same distance from each vertex of the triangle. It is also the center of a circle let's just say drawn around a triangle. The triangle. So here's what a picture of it would look like. If you got a triangle, and that triangle is ABC, each side of the triangle can have a perpendicular bisector, which would be a segment that splits the side in half and intersects it at 90 degrees. So this segment splits this side in half and it intersects it at 90 degrees. Side BC could be split in half and intersected at 90 degrees. And the same can happen with side AC. It gets split in half at 90 degrees. This point where the three perpendicular bisectors meet, call it D for right now. That point is the same distance from each of the three vertices of the triangle. And since it's the same distance from the three vertices, it's the center of a circle that could be drawn around this triangle. Okay? Every triangle can have a circle drawn around it. And that circle goes through each of the vertices. Can you picture it? Can you picture it? Can you picture it?
Yeah.
There you go. A circle that goes around every triangle. And it goes through each vertex. Point D would be the center of that circle. Point D is the circumcenter. Point D is where the perpendicular bisectors of a triangle all meet. These three distances, from A to D, and from B to D, and from C to D, they're all equal to each other, aren't they? They're all radiuses of a circle drawn around the triangle. Okay? So there's a bunch of things that are going on when you're talking about the circumcenter. It's where the three perpendicular bisectors meet. It's the same distance from each vertex. These perpendicular bisectors split all the sides in half. And it's the center of a circle circumscribed about the triangle. Got all that?
Yes.
Very good. Very good. The circumcenter is inside an acute triangle outside an obtuse triangle and on the hypotenuse of a right triangle. And there's a good picture of that at the bottom of page 319. It shows an example of each of those cases. All right, so if you turn the page and look at example 1 on the top of page 320, and if you would start reading through that example right now, I'd appreciate it. And I'm going to draw it on the wall as you read through it. Triangle HGJ. Example 1 in the middle of page 320. You're told that K to Z, L to Z, and M to Z are perpendicular bisectors. So if these three segments that meet right here at point Z are perpendicular bisectors, isn't this piece, H to L, equal to L to J? Okay. J to M would be congruent to M to G. And G to K would be congruent to K to H. Agreed? All right, very good. Now you got three other segments. These three red lines are going to connect the circumcenter to the vertices. What do you know about the three red segments?
All the same distance?
They're all the same, aren't they? Because the circumcenter is the same distance from each vertex. So now you're given some dimensions. You're given K to H is 18.6. And G to Z is 19.9. M to J is 14.5. And Z to L is 9.5. You're asked to find H to Z. H to Z. Isn't that the distance from a vertex to the circumcenter?
Yes.
So how far is it from H to Z?
19.9.
19.9. Very good. You're asked to find G to M. G to M.
14.5.
Very good. 14.5. Because M to Z is a perpendicular bisector. You're asked to find G to K.
18.6.
G to K. Where is G? G to K. Very good. That's 18.6. And J to Z. J,
9.5.
which is a vertex to the circumcenter. 19.9. Very good. Everybody understand?
Yeah.
Okay? The perpendicular bisectors split all the sides in half, and they intersect at 90. They're concurrent at the circumcenter. The circumcenter is the same distance from all the vertices. Okay? Example 2 asks you to find the circumcenter of a triangle. Find the circumcenter of triangle RSO. So find the circumcenter of triangle RSO with vertices. R is at -6, 0. S is at 0, 4. And O is at 0, 0. So when you're doing this in today's practice, you're going to draw the coordinate plane. And boy, if you have graph paper, this will be a lot easier. When you do the assignment, don't take it out right now, okay? You're going to plot these points on the coordinate plane. You got -6, 0, so let's say it's about here. -6, 0 is point R. Point S is at 0, 4, so 0, 4. That's point S. And point O is at 0, 0, so here's point O. That gives you a right triangle. This blue right triangle. You're asked to find the circumcenter. The circumcenter is where the perpendicular bisectors meet. So, do you see side SO? What point along the y-axis would split that in half? 2. So wouldn't a line going through 2 be that perpendicular bisector? Does everybody understand that? or see that? That this line going through 2, parallel to the x-axis, would be a perpendicular bisector here. That line would be y equals 2. Where would a vertical line have to go along the x-axis to split that side in half?
3. Negative 3.
Okay, at negative 3. So look where this would go. That would be at x equals negative 3. If 2 of the perpendicular bisectors meet at one point, don't you think the third one will be on that point? Okay. So what are the coordinates of this point?
Negative 3, 2.
Negative 3, 2. Bless you. So when it said to find the circumcenter of triangle RSO, the circumcenter will be located at negative 3, 2. Any questions about the circumcenter? It's where the perpendicular bisectors meet. It's the same distance from the vertices. It's in an acute triangle, outside an obtuse triangle, and it's on the hypotenuse of a right triangle. Look at the top of page 321. The incenter of a triangle. Is where the angle bisectors meet. And is equidistant from the sides of the triangle. Incenters, where the angle bisectors meet, and it's equal distance from the sides of the triangle. It is the center of a circle inscribed in the triangle. Let's see, it is the center of a circle inscribed in the triangle and always inside. So take a look at example 3 on page 321. Alright, in this example, you are told that J to V and K to V are angle bisectors. So if they're angle bisectors, they split their respective angles in half. So these angles would be congruent to each other. Find each measure. The distance from V to KL. V to KL. V right here. If J to V and V to K are angle bisectors and they meet at point V, then they are the incenter. Okay? The incenter is the same distance from the sides of the triangle. So this segment that goes from V to W is the distance from a point to a segment. They're asking for the distance from V to KL. So they're asking you for this distance right here. So how far would it be from V to KL? 7.3, very good. Because V is going to be the same distance from all three sides, isn't it? They ask you for the measure of angle VKL. VKL, so that would be this angle up here, wouldn't it? The blue angle. Alright, so in order to find that measure, let's look at the big triangle around the outside. L, J, K. This angle is 106 degrees, isn't it? If this little angle is 19, what's this angle? Right above it. 19, because J to V is an angle bisector. So what is this entire angle? 38. If you take 180 and you subtract 106 and then you subtract 38, how much is left? 36? So you got 36 degrees left that has to represent this entire top angle right here. This has to be 36 degrees. If this big angle has to be 36 degrees and K to V is an angle bisector, what's the measure of this blue angle? 36 divided by 2 is 15 degrees. No, it's not. 18 degrees. So those are the types of problems you're going to see today in relation to circumcenter and incenter of a circle. Does anybody have any questions? All right, turn it over to page 323. Problems 1 through 10. And 12 through 19. Check headline for homework, please.